Welcome everyone. Let's solve some problems for limit properties. Limit of fx as x approaches to 10 is equal to 5 times limit of gx as x approaches to 10 is equal to 4. And limit of hx as x approaches to 10 is 7. These are given to us and it wants to compute the following limits. When I look at this, the first thing I realize that I know what the limit of fx is equal to, I know what is limit of hx is to, but the question is what is limit of gx by itself. I know these, but I don't know that. So if I divide every part with 5, I'm gonna see that limit of gx is equal to 4 over 5. So now I know all the limits by itself. I can use my limit rules to compute the following limits. So first I want to write this as 2fx plus, I'm basically separating the limits. I know that I can do these by the rules that I learned. And now I know that I can put the 2 and 5 outside of it as well. So I can say that this is equal to this. Now I know what this is equal to, and I know what this is equal to. Therefore, let's see, our fx as x approaches to 10 is equal to 4. So 2 times 4. And our limit of hx is equal to 7. So 5 times 7, and I add these. So 35 from here, 8 from here. So 35 plus 8, my answer is clearly 43. Now that I have another question, limit of 20gx minus 6 as x approaches to 10. Let's separate these and take the 20 outside of the limit. So it should look like this. Minus limit of 6 as x approaches to 10. I know that this is equal to 6 already. This part is clearly equal to 6. But what is this part? What is the limit of gx? That's the question we have. Limit of gx is 4 over 5. So 20 times 4 over 5 minus 6 is equal to these. Will cancel out 16 minus 6, which is going to be 10. Now the last question is limit of fx plus gx minus hx as x approaches to 10. So we will add fx and gx at each other. We know that we can separate these. Let's separate them. Fx plus limit of gx as x approaches to 10 minus the limit of hx as x approaches to 10. So now I know this is, let's see, this is equal to 5. For gx, I have 4 over 5. And lastly, for hx is 7. So now, let's expand every side with 5. 25 plus 4 minus 35 over 5. Now 29 minus 35 is going to be negative 6 over 5. So this was the answer of our first questions. Our second question. So there's a limit. There are two limits that is given to us again, and it wants to compute the following limits again. So limit of fx over gx as x approaches to negative 5 from the right side. And what is given to us is limit of fx as x approaches to negative 5 and limit of gx as x approaches to negative 5. But what I know is, if my limit of fx as x approaches to a is equal to L, to say this, I know that I need to say these are equal to each other. Therefore, if we have a limit like this, I'm going to say that from the right and left, it's also equal to this. So therefore, when I approach from the left right, it's also going to be equal to 10. Now, let's see if we can use our limit rules here. I'm checking that if I can write this like this. So I'm gonna get this. So the issue is if my denominator is equal to 0 here, if limit of gx as x approaches to negative 5 from the right side is 0, I cannot do this. But when I check it that I'm seeing limit of this function as x approaches to 5 from -5 from the right side is equal to 8, therefore I can do this. Something over 8 and the limit of fx as x approaches to -5 from the right side is 10. If I want to simplify it one more time, it doesn't really matter, it's the same thing. I get my answer. And now we have this limit. Now this time limit of the function as our x is approaching the -5 from the left side. First, I know that none of the denominators are equal to 0 since they're given to us. And I know that even if it's from the left, since I know this equation, since I know that for a limit to exist like this, it has to, we don't need to confirm this anymore. So therefore, I'm gonna say, I can write this as 10 over 8. Let's not do it like this actually. Let's see it first. Fx over gx minus limit -5 with the here from the left side gx over fx. So now I know that I already showed this part here, which is 5 over 4. It's the same thing here, but the only difference is now it's gx over fx, which is going to be 8 over 10, which is 4 over 5. It's the same thing. And if we expand every side with the correct number, 5 for here, 4 for here. So we get 9 over 20. And now we have answered the following limits. Now that our x is approaching to a value. So let's see, a limit of in the parentheses we have, it's better, maybe it could be better if we show it like this. So limit of x to the power 35 minus x squared, and this is also squared. I know that if I remember correctly, if I remember my rules, if I have something like this, and there's a power of it, doesn't matter. And the way we learned it was r over s, but still, let's say it's r, what doesn't matter. I can say this is equal to this, right? We learned this. So now what I'm gonna do is we call this plugin. We just put the x for the x we have here since this, well, I cannot do this if I get something like 2 over 0 or like a number over 0, which is not defined. But in this case, when I put this in, I'm clearly seeing that I don't get anything that is not defined. So therefore, 1 to the power 35 is 1 minus another 1 from here, and this is squared. This is 0. 0 squared is clearly 0. And we have another example for now. To see that if I can just put 1 for x, I need to see that if my denominator is equal to 0, because if it is equal to 0, I cannot work with this. But I'm seeing that 1 minus 3 is -2, therefore I can work with this. 5 plus 4 over -2 is going to give me the answer, since I don't deal with any type of issues here. Now, now I'm seeing that my denominator is going to be 0 if I plug this in. Therefore, we have some issues here. How are we gonna solve this though? The thing is, we need to figure out a way that we save ourselves from this. Therefore, I can evaluate the limit, because as long as this is here, there's nothing I can do with this limit. So therefore, I'm gonna divide x to the power of fourth minus 1 to x minus 1. So I want to write this as multiplying of two equations, fractions. So I'm trying to figure out a way that I can save myself from this x minus 1. So for those who doesn't remember how to divide these, basically I'm trying to create the biggest power in the dividing in that I'm doing, so I will save myself. I'm gonna keep dividing it as until I can save myself from the x. So x cubed, and when I multiply these, I'm going to get this, and when I I'm gonna do this part by myself a little bit. It's not hard to do. It's from high school. So 1 plus x squared, I get another x squared minus x. So this is going to give me minus 1 plus x, which is the same with this. So therefore, if I add another one, these will cancel out. So this means this is equal to x minus 1 times x cubed plus x squared plus x plus 1 if we didn't do anything wrong with the division. You can check it by yourself. You can do it by yourself as well. You should solve these problems before me as a practice. So now I can write this as x minus 1 times x cubed x squared x plus 1 over x minus 1. Now I'm finally saving myself from the x minus 1s, and therefore now I can use the plugin 1 plus 1 plus 1 plus 1, which is clearly 4. Is going to be answered. As I said, if we didn't do anything wrong with the division, it should be fine. And my goal is saving myself from the highest power here. So I'm going to divide it until it's completely gone. And our last question, explain why a limit of x is approaching the 0 from the left. We have 1 over x plus 1 over x squared is equal to infinity. So to understand this, of course, when I look at this, I'm seeing that if I plug in, I'm getting something like this. So what is this, right? I cannot work with something like this. But if I know the graphs of these functions, of course we're in calculus, so we have to know these graphs. For 1 over x, my graph should look something like this, right? And my 1 over x squared should look something like this. So therefore, when I approach 0 from the left for 1 over x, my 0 is here. I'm approaching 0 from the left side. I'm seeing that it is going to negative infinity. And for is this question correct? I checked my book and I realized that there's a mistake in this question, and that is we're supposed to approach the 0 from the right side, since if I approach it from the left side, this is not correct, therefore. So now let's solve it according to the right way of it. So now I'm approaching 1 over x from the right side of the 0, therefore I'm seeing that my function is going to infinity. And for the 1 over x squared, I'm seeing that from the right, when I approach to 0, this is also going to infinity. Therefore, when I add these to each other, I'm going to see that this is equal to infinity. The better way to write this down, it's easy to see it like this, but if you want to show our work, you will say that this is equal to 1 over x squared. And since this is equal to infinity, and this is also equal to infinity, we will say this is equal to infinity.